Hi guys. Today we're doing Unit 3 review. We have a packet for that. The test for Unit 3 is going to be when we come back from the spring vacation. Most probably the test is going to be similar to these problems. So I'm solving with you problems similar to the ones on the packet. The ones on the packet you're supposed to do them in your own and go over them during the spring vacation. We're going to try to do these over the coming couple days. So example 1, it's talking about we have a pole and this pole has two wires attached to it, one on each side, forming two right triangles. Part A, we want to find how tall is the pole. How long is this? If we look at this right angle triangle, we know only one side is 24, but we know also an angle. Since we know only one side, we cannot use Pythagorean theorem, so we are going to be using the trig functions. We know sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So here the 35 degrees, I want to find the opposite. I know the adjacent is 24, opposite, and adjacent, we found them on the tangent. So we're going to be using tangent. Tan angle 35 degrees equal opposite, I'm going to call it x, over the adjacent 24. Tangent 35 degrees using calculator is approximately 0.7 equal x over 24. Multiply both sides by 24 to get the x by itself. X equals 24 times 0.7, which is 16.2 feet. Part B, how far from the base of the pole does wire 2 attach to the ground? How far from this base wire 2 is attached from here? Like, how long is this? We are going to call it y one more time. We know the 32 degrees. We want to find the opposite. The adjacent by now is given from part A, 16.2. So I can use tangent one more time. So tangent 32 degrees equals opposite, which is y, over adjacent, which is 16.2. Then we can find the value of tangent 32, 0.625 equals y over 16.2. I want to get this y by itself, so I multiply both sides by 16.2 or cross multiply. So we get the y equals 10.125. Part C, how tall is wire 1? Want to know how long is this? By now we know this side from part A, 16.2. We know this is 24. You can apply Pythagorean theorem, or if you want to use the trig functions one more time, you can do that. I know the 35 degrees. I know its adjacent is 24. I want to find the hypotenuse. Adjacent, hypotenuse, that's cosine. So cosine 35 degrees equals 24 over z. If I cross multiply both sides by z, then z multiplied by cosine 35 is equal this 24 by itself. Cosine 35, that's 0.819. So z times that equal 24. I want to get that z by itself. Divide both sides by 0.819. You get the value of z equals 29.30. For example 2, this is example 2 or problem 2. On problem 2, we have three similar triangles and measure angle NMK equals 60 degrees. NMK, this angle is 60 degrees. These three triangles are similar. So angle J from here goes with angle N, goes with angle M. The first goes with the first, goes with the first. That's 90, 90, 90. K on the top here, go with K. Over here, go with K. If you look at the triangle in the middle, it's 90 degrees and 60 degrees, so I can find the missing angle. That's going to be 30 degrees. And since the three triangles are similar, so this angle is also 30, this angle is also 30. If this is 60 and they are all similar, then this is also 60. So now we have 30-60 triangles. If you remember, in the triangle 30-60, that's 90, that's 30, that's, remember on this triangle 30-60, we said before that the hypotenuse is double the short leg, and the long leg similar to the short leg but multiplied by square root of 3. So we're going to be applying this on this problem. What is the length of NK? We want to find how long is NK. This is the 30 degrees, so this is the short side. So if or the short leg. If I know the short leg, how can I find the long leg? Or how can I find the hypotenuse, NK? Over here you want to find the hypotenuse, NK. Hypotenuse equal 2 times the short leg, but the short leg is 7.5. So the hypotenuse, which is NK, is equals double 7.5, which is 15. What is the length of segment NM? NM. By now I know this hypotenuse of the first triangle is 15, which is the long leg on the second triangle. So now I know the long leg, and I want to find NM, which is the short leg. We know that short leg multiplied by root 3 should give you the long leg. And the long leg, that is NK. And the short leg is MN. We want to find MN. So MN times square root of 3 equals long leg, which we found before, equals 15. Now we want to get this NM by itself, divide both sides by square root of 3. Then we don't leave the square root of 3 on the denominator, so we multiply numerator and denominator by square root of 3 over square root of 3. Square root of 3 times square root of 3 give you regular 3. 15 is square root of 3 divided by regular 3. 3 goes into 15 5 times, so it's 5 is square root of 3. Third part, prove that the measure of angle JKL is 90 degrees. Angle JKL, 30 plus 30 plus 30, that's 90. So that's example 2. Example 3, that's the stuff we just were working on. We have a parallelogram, as you can see. How did I know that this is a parallelogram? I see over here 8x, 8x. So now one pair of opposite sides are congruent. I see 3x, 3x, so that's another pair of opposite sides congruent. So this is a parallelogram. Because the problem is saying give the most descriptive name for the figure, justify your answer. So now, since opposite sides are congruent, 8x equal 8x and 3x equal 3x, then the quadrilateral is a parallelogram. Now solve for x. You want to find the value of x. We know that parallelogram, the two diagonals bisect each other. So this 4x minus 5 is going to be equal to 3x plus 5. That's going to be your equation to find x. Subtract 3x, subtract 3x. 4x minus 3x, that's 1x. Bring down the negative 5. The 3x over here is gone. Bring down the 5. Add 5, add 5, x equals 10. Find the length of the longer side. If this is 3 times x and this is 8 times x, so the longer side is 8x. So longer side equal 8x. We know that the x is 10. 8 times 10 equals 80. That's example 3.